Hi everyone, this is Mr. Chang, and we are learning lesson 6 about solving radical and rational equation. As we watch this video, you can complete the notes. I will also put the link on Atrium so you can review if you want to. Okay, so in this unit we learn two types of equation, rational and radical. Radical is the one with a square root, and rational is the one looks like a reciprocal function. And actually, we have learned how to solve them in grade 11. In grade 11, we also have unit 2, if you remember. We have radical function, and then we learn how to solve them. Basically, you isolate the square root, and then you square the equation. Then you get rid of the square root, and then you can solve it. And then for the rational equation, you multiply every term by the common denominator, then all the denominator will be gone. Okay, so like this year, so we learn it in grade 11, but in this unit, they use a graphical approach or like use a different approach. So let's take a look. First, any solution to an equation is called a root. So in this lesson, we'll learn how to determine the solution using graphic calculator. So because in the diploma exam, you always have a graphic calculator, so you don't need to do it algebraically, but you could, but there is graphic calculator available. All right, now first, let's fill in the blank. These are some terms. This is actually from a grade 10 workbook. Fill in the blank. The zeros of a functions, the x-intercept of a graph. So when you're talking about a graph, you have a graph in front of you. So you have x-intercepts and a zero of the function. Well, what make the function equal to 0? And the roots, when you have an equation, we say a root of the corresponding equation are all the same number. So because of this, we can graph any equation, and then you look for the x-intercept, and that will be your answer to the corresponding equation. So it's very handy. All right, so let's look at this equation. In a physics class, students are given this equation. All right, so whenever you are given an equation, you need to understand what the variable means. So here, t is in second. It means the time it takes for the pendulum to swing back and forth. So it is the period. And L is the length of this string. L is the length of this string. T is the time it takes for it to go back and forth. Okay, so understand the context. And now when you read the question, you just follow what it asks you to do. Write but do not solve a radical equation that can be used to determine the length. So determine the length, I need other information. Given you have a simple pendulum that has a period of 1 second. So which means t is 1. So therefore, you plug everything in. Like when you have an equation that have two variables, you can't solve it. But then if you have one number, so 1 equal to 0.2 root L, you have one equation unknown that can be solved. So that will be the answer for part A. So just solve it, right? But it says do not solve. So what are we trying to do? B, explain how the length of such pendulum can be determined by using the x-intercept of the graph. Okay, so you want to make it into a graph. So how can you make it into a graph? Move everything to one side. All right. So you have an equation that has a 0. You move everything to one side. And now, what do you graph? You graph this equation. You turn that into a y. You graph this equation. Why do we do that? Because whenever you have a graph, like this is a graph, like the one we just, like here, this one is an equation. It's not a graph. Graph, you need two variables. This is a graph. When you make a graph, the x-intercept will give you the roots for the corresponding equation. And the corresponding equation means you need to make one side equal to 0. Because when you find the x-intercept, it is when y is 0. So by making that 0, graph it, you will have the answer. So finally, sketch the graph. Okay, so let me like use transformation, you start with this. Okay, you start with root L. Root L is something like that. It will cross the point 1, 1, right? It start at 0, 0, cross 1, 1. We look at transformation. 0.2 will be A. Compress it by 0.2. So now you have a flatter graph that's like this. It will cross 0.2. Okay, so the scale is not quite right. Finally, you move everything down by 1. So you move everything down by 1. Okay, so it will cross somewhere there. So it says approximate. Okay, so down by 1. So you need to like approximate where it is. If you put in a graphic calculator, you will see the answer. Okay, so this is example number 1. So let's try another example. Now we have a more like we have a grid here. We can do it more accurately. A partial graph is given. Okay, so this is a graph is given. State the 0. Okay, well the 0 is here, so it's -2. State the root. Oh, well, uh, f of -2 will give you 0, right? Because this point is -2, 0. So that's whenever we say the function equals 0, the function is y equal to 0. So the root is -2 as well. Use the graph to determine to the nearest whole number the solution when the function, this is my function, equal to 3. So if this is y1, y2, 3 is here, y equal to 3, right? Like this is, could be my y1, this could be my y2, right? Left side, right side. Where they cross is the answer. Okay, they cross at 7. The answer is they cross at 7. Find the root when you have this. Well, just move it around. Move the 4 to the other side. Now you draw a line at 4. It cross at 14. So the answer is 14. You can write f of 14 equal to 4. In each case, explain how to use the graph to determine the following. Okay, if this is f of x, now what is it f x plus 6? Okay, this is horizontal, h is -6. Everything move left 6 unit. So when is it equal to 0? Well, the original series is -2. Now you move the whole graph to the left 6 unit. So the answer is -2 move to left 6 unit, -8 is the answer. Next one. Um, okay, so you need to find where it crossed at 5. All right, it crossed at 5. Look at the graph. It crossed at 5 at 23. It crossed at 5 at 23. Right? Did you see that? It crossed at 5 at 23. And then the graph have been moved to right by 3 units. So f of 23 according to the graph should be 5. Now you have x minus 3. Okay, so x minus 3 equal to 23. So x is 26. You can either work with the notation, right? This part same as this part. You get the answer. Or if you look at transformation, it crosses at 23, you move right 3 units, you also get 26. Okay, so both way give you the answer. And finally, consider the following. You have this and this and this. This seems like, it looks like back to unit 1 when we have functions and then you do operation of the function. You can add them, multiply them, divide them, right? Now you want to divide them. So you have this divided by that minus 5 equal to 0. Like they say graph it, you find the answer. So like in grade 12, looks like they want you to know how to graph it, find the answer. Like in grade 11, we actually do the algebraic work. So anyway, now one way to do it, well, you graph it, you see the answer. Let me do it algebraically. I multiply everything by the LCD. The LCD is x minus 1. I multiply every term by x minus 1. So the first term become this. The second term become this times x minus 1. The other side, 0 times x minus 1 is still 0, right? So this is how we learn in grade 11. And now you distribute. Oops. Okay, now you distribute. Doesn't let me distribute. Doesn't let me write. Okay, you distribute. Negative 2 minus 5x is negative 3x. Negative 3 uh, plus 5 is plus 2. All right. So you just solve it. Dot, dot, dot. After some time, x equal to 2 over 3. You graph it, see if you get that answer. Okay, part B, square root. Okay, you follow what this notation tell you. For the f of x, you root it. Okay, don't miss that part. And then for this part, what does this notation mean? G of x. Put h into g. Put h into g. So this is h. I put it into g. Okay, and then you can solve it. Right, in grade 11, we learn how to solve. You square both sides. Like if you square both sides, this side become no square root. This side you need to FOIL. This is x plus 4. When you FOIL, you have this, right? Don't forget to FOIL. And then you move everything to one side. And then you solve it. Plus 6x plus 19 is not a nice number. So you do a quadratic formula, you get the answer. If you look at the graphical, look at the graph, you get the answer. Okay, finally, this over that. Oh, okay. That's look interesting. This one over that one equal to this one over that one. And then your calculator know how to solve it. Okay, that's it. So that's today's lesson. So it's not a lot. It's about graphing, working with some function notation, graph it, look for the answer, like things in terms of transformation. Just combine everything we have learned. Okay, all right. So I will again put this on Atrium so you can review it if you need more time. And I will also have a shared document, and then you have ask question like homework questions and all that, and and I will find time to answer you, and then the answer can be shared to everyone. So I don't need to answer multiple times. I just need to answer once. Okay? All right. Be good. Have a good day. See you, everyone.